total number of cases. I misled you with my previous statement on what Y was. Y is the total cases in the US. The X is just from March 10th. Sorry about that. So what we're going to do here is we're going to replace the Y value in this equation with 1 million. So that equals 908.6304 times 1.343852 to the X. And now what we need to do is we need to solve this. So we need to identify, hey, what's happening to X? What's going on here? It's an exponential function. We have 1.343852 raised to the X power, and then that, whatever that is, gets multiplied by 908.6304. Sorry. So what we do is we got to work backwards. We got to undo it so that we get X equals, right? That's how we solve things. So we got to first isolate this. Isolate the exponential. We're going to do that by dividing by this 908.6304, divide by our A value. We do not multiply these numbers because this is being raised to the X. And if we don't know what X is, we don't know what that value is. So we're going to undo this being multiplied by that by dividing. So divide by 908.6304. 908.6304. Excuse me while I put this in the calculator. 1, 2, 3, 1, 2, 3. 908.6304. We get approximately 1,100.557 equals 1.343852 to the X. And I'm going to use the value that I have in my calculator here. So I have the value, I'm going to use like that value instead of this decimal approximation. It's still not that important. So now we need to undo the fact that this X is in the exponent. We could just guess and check. We could put some numbers in and be like, this to a power. When do we get about that? What we're going to do instead is we're going to use the inverse to the exponential function. And the inverse to the exponential function is the logarithm function. Now we could take log base that fun number and then use our change of base formula, or we can use the property of logarithms, which is what I'm going to choose to do. And I'm just going to take the natural log of both sides of this equation. So natural log of this equals the natural log of this. We're going to use our logarithm property that the natural log of a to the x is the same as x times the natural log of a. To rewrite it, right, that's one of our properties. So here I have the natural log of 1,100.557 equals x times the natural log of 1.343852. To find out what x is, I just have x times this. To get x by itself, I'm just going to divide by this natural log value. So divide by the natural log over here, natural log of 1.343852. That cancels that out. Divide this by the natural log of 1.343852. Put this in the calculator, and we're going to get x is approximately, well, let me put it in the calculator. I'll get right back to you. So, go to the calculator, use my fraction button, natural log of the previous value that we just had, divided by the natural log of 1.343852. And that gives me approximately 23.697, so 23.697, or about 24 days. So about 24 days from right now, March 23rd, or not from March 23rd, sorry, 24 days from March 10th, because remember that's what X is days since March 10th. 24 days after that, we would expect there to be 1 million cases in the USA. So if we're going to the 31st, that's 21 days. So 21, 22, 23, 24. That's April 3rd. April 3rd. So if we don't stop this, we expect 1 million cases of COVID-19 in the US by April 3rd. I'm going to let that sink in for a moment. That's a lot. And that's not a lot of time. So in 8 days, sorry, April 3rd, that's 10, 11 days from now. We expect there to be 1 million cases, to go from like 40-some thousand to 1 million. Right, and this, so 21, 22, 23, 24, in 3 days, it more than doubles at this point. It's crazy. This is, oh my goodness. So, all of this data, all these problems, these 2 problems we just did, this data that we got, is a lot because we didn't really start social distancing right away when this happened, and it gave the virus kind of a chance to spread. So please, please, please practice your social distancing. We don't want this trend, and we don't have to have this trend continue. So wash your hands. Don't go around people that you don't live with. Keep 6 feet distance if you can from everybody, even people that you live with. If you can, keep a little bit of distance. That's for the best. When you're at the grocery store, when you're getting your essentials, keep that distance. And just be careful. Be safe out there. Like, if we can curb this growth rate and basically stop spreading our respiratory droplets to others, because that's how this virus gets transferred, right? We can kind of flatten this curve, and that's what everybody's talking about when they say flatten the curve. I don't know if you noticed, but these graphs were looking like this. And if we continue, it gets really, 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 really steep, and the numbers get really scary. So what we're going to try to do is right now we're like here. We're going to try to make it go like this. Hopefully. Or maybe just like this. And then down a little bit. But not so steep. We're going to, I mean, that's the goal. So please, please, please practice your social distancing. Don't go hang out with some friends just for fun. Because you could end up continuing this trend and more people get sick. Okay, be safe out there. Thanks.